Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, I hope everybody's doing good. We're just gonna start the last chapter of Unit 4, okay? And we're gonna split this chapter into two videos. This is the first one of them, and it's gonna be discussing a topic called energy resources, as you can see right here, all right? And it's probably one of the simpler topics when it comes to this unit as a whole, all right? In the previous chapters in this unit, we understood what does it mean to be an energy store, that there are different types of energies and we can't define them all to be one energy, all right? And then afterwards we studied that there are some important ones, such as heat energy, such as kinetic, gravitational potential, and many others that we talked about in chapter 1 of this unit, but not all of them we went deeply about. Now, this chapter, the last one, talks about how do we make use of this energy. All right, so when you know that something has a store full of energy, because we studied that you can convert this energy into other shapes, all right, the entire point of the chapter is how can you make use of something that has high energy. And by making use of it, I'm talking about either turning it into heat energy that's useful to us, or the main important point we're going to focus about, which is turning this energy into electricity. Most of our appliances operate with electricity, unless we're talking about stuff that take energy from gasoline straight away, such as cars and stuff like that. But I'm talking about anything inside the house, anything inside a school building, a hospital, the lights in the streets, everything operates on electricity, and electricity doesn't come from nothing. Electricity comes from another energy source that we changed or converted to become electricity. So we're going to study those energy resources, all right, that we can turn into electricity afterwards, all right? And that's going to be the first part of the chapter. The second part focuses completely on how do you turn this energy resource into electricity, and then it makes a big comparison between all the energy resources that we're going to study, which ones give you more electricity, which ones are healthy, which ones are unhealthy, which ones are reliable, which ones are not reliable. We're going to discuss also which ones are renewable, which ones are not renewable. So it's basically telling you that there are way too many ways for you to generate electricity, but we're going to discuss the different ones and which ones should you apply in certain conditions and stuff like that. All right. Starting off, in order for you to create electricity, you need something to take energy from, and we call this thing an energy resource. An energy resource is defined to be any big store of energy that can be used to generate electricity or heat a system, all right? But we're going to focus mainly on generating electricity using this energy resource, okay? So as long as you have an energy resource and you can use it to turn it into electricity, that's what we're going to be focusing on, and those are the types of energy resources we're going to be studying, all right? Scientists have put energy resources into two categories, all right, and it's very important for us to know the two categories. They said that some energy resources are renewable, while others are not, so they call them non-renewable. Okay, and they defined renewable energy resources to be any energy resource that seems to be infinite. All right, you'll never be asked to define what's this one and what's that one, but it's very important for you to understand it. Talking about stuff such as sunlight. Sunlight cannot run out. So even if you place 1 million solar panels on planet Earth, they will not make the sun run out. Okay, if you place a wind turbine, okay, and it's being spent, like it's spinning around because of the wind is not gonna run out. The wind happens because there is gravity between Earth and the moon. And the gravity between Earth and the moon won't run out. So even if you spin it, the wind turbine, like that's not going to make the wind disappear, if that makes sense. If you create a power station and it's just using stuff like the tides of the sea, all right, that's not going to make the tides of the sea stop just because you're using them to generate electricity. While on the other hand, if we highlight the other topic I'm going to talk about, which is the non-renewable ones, we're talking about stuff such as fossil fuels in general. Those, if you go to the shop, okay, and you buy some gasoline, you put it inside the car, it will run out. It won't just generate again, and it won't come out of nowhere to your car. All right, so that's why we call it a non-renewable source. Same if you have a generator at home and you get some gasoline again, put it inside the generator or gas or whatever it is, eventually it will run out. So those are non-renewable, because if we manage to somehow spend all the gas and all the oil in the earth, that's it. It's over. None will come again until a very, very long time. And since we are spending more than we're saving, then you can define it as a non-renewable, because that's also an approach some scientists talk about. They tell you if you're talking about an energy resource and humans are using it more than it's being generated, then it's non-renewable. All right? Now, talking about renewable energy resources and non-renewable energy sources concerns us when it comes to which ones we can use to create electricity. We're going to start with the simpler ones because they're less, and I'm talking about the non-renewable ones. Okay, the two main ones people actually use to generate electricity when it comes to non-renewable energy resources, they use fossil fuels in general, which we define in Arabic as al-mahruqat, or stuff that we can burn to create heat, and this heat we can turn it into electricity. So many stuff you can burn in order to achieve this. So when it comes to fossil fuels, some people use coal, okay, which is made out of trees. Some people use oil, and a lot of stuff comes under oil, you know, because there is diesel, there is normal gas, whatever it is, but all of them are considered to be oils. And lastly, a lot of people use, sorry about that, a lot of people use what we call natural gas. Okay, all of these are fossil fuels because you burn them, and by burning those, depending on which one you're using, you create a lot of heat energy, and there is a way for you to use this heat energy to create electricity afterwards. Okay, now another example for the non-renewables is nuclear fuels. Though we're not going to go deep into either of them, like too deep, but the idea of it, both of them basically work in the same way, which we're going to discuss in a little bit. Okay, the common thing between fossil fuels and nuclear fuels, is that once you use them, they run out. All right, so there is there is a lot of fossil fuels in the earth, but you can make them run out if you overuse them, and that goes the same for nuclear fuels. Okay, now going back to the renewable ones, there are more examples of it, but again, it's nothing complicated. You're just gonna start asking yourself of how do people generate electricity in a healthy way, something that doesn't release greenhouse gases, something that doesn't run out even if we use it a lot. Okay, and if you think about that, there are many different ways. A lot of people use water. There are two ways that use water. Okay, there is also the common one which we all know, which is to do with sunlight. All right, and there is also another one we discussed in one of the previous classes, and I'm gonna mention it right now. And that's gonna show you that there are way too many different ways in order for you to generate electricity. Sorry, the one that I didn't mention also is that people use wind to also generate electricity. So I'm gonna name them, and our basically the entire purpose of the lesson is to know the difference between each one of them, because some would work in some situations and some would not. Starting off with the wind, you can generate electricity if you build big wind turbines, and those wind turbines start spinning whenever wind hits them. All right. You can also generate electricity by using something that we call solar energy. Okay, and solar energy, just to not confuse you right now, I'm talking about people who put solar panels and they get their energy from the sun. Okay. Another method that we can also use to generate electricity in a healthy way and with using renewable sources is by doing something called tidal energy, which is basically waves, and those waves spin some sort of turbine, and the moment it starts spinning, it generates electricity. There's also something else that we can use using water, something we're gonna call as hydroelectric. We'll discuss in details. Okay. The other ones I didn't mention yet is we can use biofuels, which are very similar to fossil fuels, but they're healthy, first of all. And second of all, they come from plants, and we can always put more plants because plants take their energy from sunlight, if you think about it. All right. And since plants take their energy from sunlight, and sunlight will never run out, then it's renewable. There is always more sunlight to feed the plants. And those plants that, as long as they have ethanol, you can use them and burn them, and they can create some sort of energy which we can turn into electricity afterwards. That leaves one which we didn't mention yet, which is geothermal energy. Okay. Now, I'm gonna start talking about the ones that are simple quickly, and I put an explanation in detail downwards for the ones that are a bit complicated. Starting off with wind turbines. All you need to do in order for you to create electricity using wind is for you to understand the main concept behind generating electricity. Okay. In order for you to generate electricity, you're supposed to make something spin. Okay, usually they put whatever machine or device, or it's usually something that's shaped like a wheel. Okay, and as long as you make this wheel spin somehow, all right, and it starts making a turn, you are generating electricity. Why? Because inside the wheel there is a device we call the dynamo, and inside the dynamo, or the dynamo depends on how you say it, it's something that changes kinetic energy into electric energy. And this is the main concept when it comes to all of them. Literally all the types, the renewable, the non-renewable, whatever they are, all we need to understand is that we are spinning something, and when it spins, it starts creating electric energy. All right. So all the resources that I mentioned, people try to understand, how can I make this resource spin a wheel? And inside the wheel, I can just put the device which I defined as the dynamo, and the dynamo, as soon as it starts spinning, it starts creating electric energy. So starting off with the first one, it's pretty obvious. Imagine if you're trying to use wind, you need obviously a country that has winds. All right, you can't like do such investments here in Libya, because Libya, we don't have much wind. Like if you start to build windmills all of a sudden and expect them to generate your electricity, it's probably a bad investment, because they wouldn't spin often, they wouldn't spin as much, and they wouldn't create you enough electricity. Maybe in some areas, in some cities, but like usually they wouldn't work out in such countries such as Libya. Okay, but the way they operate is basically wind hits them. Okay, and there is always more wind coming if you put them in the right country. That's why they put them a lot in countries such as the Netherlands. They have strong winds in there, and they put them always near the sea or at a high place. So the moment the air or the wind starts hitting them, okay, the blades are automatically forced to start spinning around. All right, and since they are spinning in a turning motion, they will start creating electricity. Okay, mainly because there is something that we call the dynamo, and the dynamo, as long as there is movement, and the movement in this case is the spinning, it will start creating electricity. So it's pretty simple for you to understand how windmills operate. The entire purpose of you is to put them somewhere that is windy, so that when the wind hits them, they start to actually rotate, and once they rotate, they can generate electricity. All right. Now, continuing on the theme of stuff that you need to spin in order for you to create electricity, we're going to take the tidal one, which again, such inventions would work in countries that have high tides or strong tides. The moment the tide moves towards the turbine and it strikes it, the turbine will have to make a spin in this direction. Okay, and once it starts spinning, that's it. All you need to know is how to spin the machine. And when it spins, it has a dynamo inside of it, which changes the kinetic energy of the turning into electric energy, creating electric charges. Okay, and it's being stored somewhere else or used wherever it is. So as long as you place it somewhere where there are high tides, strong tides, it will keep spinning the turbine, exactly the same as this one, except for this one relies on wind. This one just relies on the tides of the water, and again, it's just something, a wheel or a turbine that keeps spinning around, and the more it moves, the more it creates electric energy. All right. Moving on again to something else that we need to spin around, which is hydroelectric. And I want you to understand that hydroelectric is the same as this diagram, exactly. Hydro stands for water. Okay, so it's kind of like saying creating electricity using water. The way they do it is they put the water at a high point. Okay, and because the water is moving from a high point to a low point, it's going to start moving in this direction. The moment it moves in this direction, it finds this turbine right here. It's going to hit it, making it rotate in this direction. Okay, just like every other example that we've taken. I want to do it in a clearer color to show you what I'm talking about. Once the water hits here, it starts making this turbine spin like this. Okay, and because it's spinning, it's connected to a generator up here, which has the dynamo device I'm talking about. It's going to start creating electricity, and yeah, electricity will just go to the buildings. All of them work in the exact same idea, except for wind uses wind, obviously. Tidal uses the tides. This one just uses the height difference between up here and down here, because if you drop something from a high point to a low point, it will move, and when the water moves, it will hit the turbine, it will spin it. All of them work with the exact same mechanism. Moving on to the next one we're going to talk about, which is also the geothermal energy. Look here again. This is another diagram for geothermal energy. Geothermal stands for high temperatures in underground. All right, so the word geothermal just talks about you finding a place in which underground it's very, very hot. Okay, and this will also help you spin a turbine in some way. Here's our turbine in the example right here. Okay, now what do? They know that the lower parts of the ground in Earth, the deeper you go, the hotter it gets. So this highlighted point at the very bottom, that's hot. They end up pouring a lot of water down there. Okay, and when the water touches the hot parts at the bottom, it becomes hot, it boils, it starts rising up here as steam. Okay, basically it's rising up as a hot gas using pipes. Once it reaches here, it enters as hot gas that's moving at high speed inside the turbine, causing the turbine to rotate. Once it rotates, it has a generator right here, and that creates electricity, and that's it. And those are just made to like let go steam on the outside. It's totally renewable. Okay, why is it renewable? Because those layers of the ground which are hot are always there. They will never disappear. All you need to do is keep pouring some sort of liquid, so it creates a gas, and the moment the gas comes out, it will start rising up from this side. After rising up, it will enter the turbine. Because the gas is going at a high speed, it will spin the turbine, making it rotate. And once it rotates, it generates electricity right here, if you can see. It says that it's a turbine and a generator. All right, so the electricity gets generated right here because the turbine spins too much, and that's it. It's just connected to the electricity pole that you can see right here, right? The ones that we're going to talk about, which are the non-renewable ones, they also have the exact same things. I'm talking about biofuels, I'm talking about fossil fuels, and I'm talking about nuclear fuels. You can take this example that I'm going to show you right now for either one of the three. Whether it's a fossil fuel, a nuclear fuel, or a biofuel, they all operate in the same way. They take the fuel and they burn it. Once it burns, it creates high steam, okay, which is kind of like a hot gas. The hot gas enters a turbine, and the moment it enters a turbine, it's connected also to a water system from the other side. Both of these allow the turbine to start spinning. Once it spins, it's connected to a generator, which creates electricity because of the spinning, and that's it. It's put outside. This is what we use mostly in Libya, by the way. It's the most common one. We basically just have a chamber, and inside the chamber they put the coal. Okay, I need to explain it to you, just if anybody is interested in how electricity is being created in such countries, because we rely 100% on fossil fuels when it comes to creating this. All we need to do basically is bring the fossil fuels, put them in a chamber. Once you burn them, they create hot steam. All right, this hot steam, you need to pour water inside the turbine. The turbine, the moment the water reaches the hot steam, it will turn into vapor. Okay, and this vapor has a lot of energy, so it will start spinning the turbine very quickly. The moment you achieve spinning the turbine, you will need to connect it to a dynamo, and that's it. You're basically generating electricity at that point. Right, so what I want you to understand is out of every one that we mentioned up here, talking about wind, tidal, biofuels, geothermal, fossil fuels, nuclear or hydroelectric, all of them work with the exact same way. And this is why I wrote right here that regardless of the energy resource that you're using, electricity is generated by turning a turbine. So always you're gonna end up with something that spins around. We name this something that spins around the turbine, and the moment it starts turning, we can turn it into electric energy. So even though we can use it using wind, you can do it using tidals, you can use it, do it using geothermal resources, hydroelectric, biofuels, fossil fuels. You can do it with coal or with oil or with natural gas or with nuclear fuels. It doesn't matter. All of it relies on changing this energy resource into kinetic energy somehow, which means this energy resource should help you spin something somehow. And the moment this turbine starts spinning, that's it. You're just gonna connect it to a generator, and the generator will have electricity. Okay, it's very similar to the bicycles, if you've seen them before, the ones that don't work until you start basically cycling around. Some bicycles, you can use them to even charge your phone. Okay, all you need to do is cycle around, even though they don't create that much electric energy, but yeah, it's the same concept they use there and here. That only leaves one thing, which is solar panels and solar energy. This is the only one that doesn't require you turning it into kinetic energy, because no need for details here. But all you need to know is that they use some sort of semiconductors and transistors, and those transistors are sensitive to sunlight and like the strong lights basically. And yeah, they're able to change the energy that comes with it inside the wave into electric energy. They're very, 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 very like it's unique, making them the only one that don't operate in the other way that we spoke about spinning a turbine and whatsoever. All right. What's important out of everything that I wrote here, and right now it's a lot of scribbles, is that you are supposed to understand the differences between each one of them, and you're supposed to be smart about it. Okay, so some of them, all of them, sorry, have some good sides and some bad sides. Starting off about wind, wind is very nice, except for it's slow, it doesn't give you energy that fast, it's dependent on the weather, therefore it's not reliable. Okay, because you cannot guarantee that every day of the year you will be able to generate electricity. No. If it's a way where there is no that there is no wind, then you can't rely on it, making it unreliable. But it's very nice because it's renewable, it's healthy, it doesn't release any fossil fuels to the environment. So it has good sides and it has bad sides. And focus that on every one of them, you'll see that none of them have only good sides or only bad sides. All of them have good and bad. Go to the solar energy. Okay, again, they're very nice. They're actually amazing, but their issue is that they're also not reliable. Oh, sorry, I'm very sorry. They're also not reliable. Okay, what do I mean by that? If you face a day where the weather is cloudy or it's raining and you want to generate electricity using solar panels, you can't because the sun is hidden behind clouds, making it impossible for you to actually generate electricity using solar panels on such days. Okay, what's good about them? Well, they're renewable. Okay, they're not that expensive. Like, somewhat, putting solar panels can be cheaper than putting wind turbines, if that makes sense. Okay, because they're big and whatever. And at the same time, as long as it's a good day, you're basically generating electricity for free. All right? So they don't cost you much. Their cost only comes when you pay for them, like when you install the solar panels and everything. After that, that's it. They're cost free. All right. So it's a one-time purchase cost. All right. Moving on with the tidal, very similar to what I spoke about. They're not reliable because if you're on a bad day and there are no tides, then you can't do much about it. Okay. But they also come with the good side, the fact that they're renewable, the fact that they are very healthy, they don't release any greenhouse gases, all of that is good. All right, so the bad side is only the fact that they're not reliable. Same as this one, same as the wind, same as the solar energy. Going to hydroelectric, okay, this one doesn't go on the same category of being not reliable. Yeah, no, it's very reliable because if you can focus here, the way we do hydroelectric is usually people, oh, why did it stop? Hello. Oh, I think I clicked something wrong. I fixed it. If you look at hydroelectric, such as this one, usually people use them using dams. Oh, my man. They use them with dams, okay? And a dam in Arabic is said, which is a lot of money, a lot of water reserved somewhere. And since you have this water reserved there already, you kind of are predicting how much water you need already. Now, the only case they turn unreliable is if the water source that you're using becomes empty. So imagine if you're filling up the dam using a river and suddenly the river dries out. Then you're going to be stuck because you don't have water inside the dam and you can't use the hydroelectric system anymore. All right. Moving on to the next one, we're going to talk about fossil fuels. Okay, fossil fuels are very reliable because you can store them, the plants that you need to burn. All right, and they're very healthy for the environment. The only issue they have is they don't release a lot of heat energy. Like you compare them to something such as fossil fuels they release a lot of heat energy, but biofuels do not as much. All right. And lastly, geothermal are very nice, except for you can't put them in a city next to people because they release a lot of steam. All right, and it can be unhealthy sometimes. But they're very nice, except for they just do some releases, some gas releases. And those gas releases, unfortunately are not healthy. So that's the downside about them. Even though they're very nice, they're very fast, they're effective, they're reliable. The issue is you can only put them in certain places. You need to be away from people in cities. And secondly, you need to be in a place where the layers of the ground are actually hot. Okay? Because not everywhere the deeper layers of the ground are hot. No, you need to find a place in certain rocks in certain conditions where it actually is hot there in order for you to do the entire process of you pouring water, if you can remember here. In order for you to pour water here and the water needs to heat up, the ground needs to be hot. And you need to find this location where the ground needs to be hot. And it needs to be away from people because all the gases that you release afterwards, they might affect the people around. So those are the downsides about it. Moving on, fossil fuels are extremely reliable because we have a lot of fossil fuels on Earth, especially in a country such as us. What's their issue? The issue is that they're expensive. They release greenhouse gases. Okay, and they're not clean. Those are the downsides. The good sides, well, they're reliable. They release a lot of energy. Like you can create a lot of electricity using them. And they're easy to get to. All right, now going on to nuclear fuels. Again, they share the exact same features as fossil fuels when it comes to reliability and releasing some bad stuff in the environment and the surrounding. All right, now this is literally the lesson. There isn't much about it. The entire point you need to know is that in order for us to generate electricity, we just need to spin something. All right, and in this case, you can see that it's a turbine here, a turbine here, a turbine here. It doesn't matter. When we discussed the example also about wind, we said that in windmills you need to spin the turbine. When we said about the tides, you need to spin a turbine. The moment you start spinning the turbine, we put something called a generator. Okay, and the generator, all it does is it turns the energy of the spinning, which is kinetic energy, into electric energy. The only one that doesn't work in this way, as we said, the solar panels, it has its own way into turning stuff into electric energy. Finally, we need to have a comparison. I've placed a table right here so we can read through it quickly. All right, and this table just gives you a quick description about every one that we spoke about from the energy resources. Okay, starting about fossil fuels. It says that fossil fuels are combusted to heat water to produce steam that can turn the turbine and generate electricity. Okay, so you need to heat them up. Once you heat them up, they create a lot of heat energy. This heat energy, once it touches water, the water turns into steam, and this steam is going to start spinning the turbine. Nuclear. Okay, it says nuclear fuels are reacted to heat water to produce steam. It's again the exact same thing that fossil fuels do, except for instead of using fossil fuels, I'll use nuclear fuels. Okay, biofuels, again, crops are grown to produce ethanol and methane, which can be used to place fossil fuels. So again, instead of you spinning the turbines using heat from fossil fuels or nuclear fuels, you can do the healthy thing, which is using biofuels. They're renewable, they're healthy, but they're not as effective, you know? Wind is very simple. Wind is used to turn turbines to generate electricity. Like wind is going to hit the turbine and the turbine is going to spin. Hydroelectric, water is stored at a height, and when released, the moving water is used to turn turbines and generate electricity, as we've seen in the dam example. Tidal, water is stored in height by tidal verge at a height low tide. When released, by moving water to turn the turbine to generate electricity again. This can be done, by the way, as you can see right here, artificially, where people on purpose put water at a high place and then they release it, and once they release it, it hits the turbines and it spins. And sometimes they place it in countries that already have natural tides and they just put it there and the turbine keeps spinning non-stop. Okay, and then we have the last examples that we have right here. We have the solar cells, the solar panels, okay, and we also have the waves in display in front of us. Even though I don't see them asking about waves, okay, because usually they use the word tidal, even though they're the exact same thing, by the way. It's just that tidal is artificial. People actually put the water on top on purpose, while this one is just natural waves. But you can think about them the same way because it doesn't mean much to you. Geothermal. Hot rocks underground are used to heat water to produce steam that turns turbine. You can see that the entire idea is for you to create steam or some sort of wind or water or whatever to spin a turbine, and that's it. You have the difference between a solar cell and a solar panel, which is important. Okay, solar cells use sunlight to generate electricity. Solar panels use sunlight to heat water, and panels produce warm waters. So the solar cells he's talking about here are the ones we normally place in front of sunlight, and they start turning stuff into electricity. Solar panels is referring to anything that absorbs sunlight in order to heat, not to generate electricity. So you see this in Tunis, they put their water tanks, they put them on the roof. And even some people in Libya do it here, but it's more common there. They put them on the roof, okay, and they put around them solar panels which are dark, and those absorb a lot of heat, therefore the water gets hot and you don't need to have heaters inside the house. You know, it's a way to heat up the water using sunlight, if that makes sense. While solar cells are straight up just generating electricity using the method that we spoke about. I hope everybody understands the lesson of the day. I know it took a bit long, 30 minutes, but the idea is not complicated. It doesn't require 30 minutes to understand. You just need to know that we have different ways, okay, to generate electricity using different energy resources. We took all of these energy resources, we categorized them into some of them being renewable, some of them being non-renewable, okay, and after that we explained them and how do people generate electricity using each one of them. All right, the main idea though is you need to spin a turbine. Okay, keep that in mind. How do you spin the turbine? Depends. If I told you it's wind, then wind will do it naturally, no problem. If I told you it's stuff to do with water, then again, you just need to make the water move and it will spin the turbine. If I told you it's fuels in general, I'm talking about biofuels or fossil fuels or nuclear fuels, then just understand that all three of them do the exact same thing, which is all they do is they heat water. When the water gets hot, it turns into steam. And this steam, what does it do? It spins the turbine. Okay, keep in mind that it's very, very simple. The wind spins the turbine instantly. The water spins the turbine instantly. What about those three? You just gotta remember that they heat water. The water turns into steam. Steam is the one that spins the turbine. All right, this makes it easy for you to memorize how they function. That leaves stuff like geothermal for you. But again, remember the geothermal just pours water underground, the water gets hot, and the water turns into steam, and then it's used to spin the turbine that you can see right here, all right? So again, it's not something you need to worry about either. And lastly, solar cells, they're not gonna ask you about the way they operate. All you need to know when it comes to solar cells, just one more time, finish up the lesson. All you need to know when it comes to solar cells right here is that they turn sunlight into electricity, and that's it. All right, I hope everybody understood the lesson. Hopefully I'll be back in school very, very soon, inshallah. But this and one more lesson and we will be done with Unit 4. And that's everything that you need to study for your midterm and your mock exam, because you've already taken Unit 1 and Unit 2, and you just need to study Unit 4. Once we're done with this, I'll try to make as many videos as possible solving past paper questions, ideas that you might face in the exam. But yeah, we just need one more video and we'll be done, inshallah. Thank you for watching. I hope you understand. And please send me a message on the application if you struggle to understand any method of the ones that we spoke about here, and I'll try to re-explain it to you better. Have a good day and goodbye.